Hey there, it's Kevin Kennedy, and today I'm going to show you how to create this simple 3D printable book rest in Fusion 360. You'll learn how to save your file, how to create two-dimensional sketches, how to extrude your sketch into a three-dimensional object, and how to add fillets or rounded edges. To get started, we'll first want to save our design file. It's a good idea to get into the habit of saving your file before you do any work. Click the Save icon in the upper left-hand corner. This will open up the Save dialog where you can type out a file name along with the option to choose its location. I'll type out one-hand book holder for the file name. For the location, you may also want to create a new project by selecting the New Project button. Within each project, you can also create folders to further organize your design files. If you're just starting with Fusion 360, then it's important to note that this is not required. However, creating folders will help you keep your files organized as you create more files. Once our name and location are complete, we can click the blue Save button. This will save your design file to the Autodesk 360 cloud. Because Fusion 360 is a cloud-based CAD program, the files will not automatically be saved to your local computer. After saving the file, you'll notice the file name now appears above the toolbar in the tab. To the right of the file's name will be the version number. Because Fusion 360 is cloud-based, you'll be able to save versions of each model. Now, each time you click the Save icon in the toolbar, you'll be given the option to write out a version description. Let's now get started with a two-dimensional sketch. If you take a look at the objects around you, you'll start to see that all objects can be broken down into simple geometric shapes. Now, this concept is the first thing to understand while learning any 3D modeling program. We're going to break down this book holder shape into some simple circles and arcs. We'll then round over the edges so they're not so sharp. To start sketching geometry, we'll first need to select the Create Sketch button in the toolbar. This will prompt us to select one of the orange origin planes. In Fusion 360, we can't sketch out in space, so we'll need to start each file by selecting one of these three planes. Now, these correspond to the X, Y, and Z coordinates of the view cube in the upper right-hand corner. When you start a 2D sketch, you'll want to think about how the object sits on a table or the ground. We're going to sketch the bottom of the book holder as it would appear lying on the table. Therefore, I'll select the bottom XY origin plane. Now that we're in an active sketch environment, you'll see that our Sketch tab is selected in the toolbar. We now have access to all of the two-dimensional sketching tools, which includes several geometric shapes. Let's start by creating a circle. I'll select the Center Diameter Circle option in the toolbar. Then, I'm going to click on the center origin point and I'll drag out with my mouse. Notice as I drag out with my mouse that the dimension input field appears. It's here that we can type out the diameter of the circle where the user's thumb would go. I'll type out 24 for the dimension, and we'll then need to click with our mouse to set the circle in place. Notice how the circle command remains active unless we hit the escape key or we activate another command. We want to create a second circle for the outer edge of the holder. Once again, I'll click on the center origin point and I'll drag out with my mouse. This time, I'll enter a dimension of 35 millimeters before clicking to place the circle. At this point, we'll want to create the circles for each end of the book holder. I'll click anywhere to the left to place another circle. I'll make this one 10 millimeters in diameter. Next, I'll click to the right of the initial circle to place another circle. However, this time, I'm going to click without defining the dimension. Because we want these two circles to always match, we can use an equal constraint, which will force the dimensions to always be the same. In Fusion 360, constraints allow you to relate one sketch entity to another. I'll hit the Escape key on my keyboard to clear all commands. Then I'm going to hold down the Shift key, and I'll select both circles. Notice how some of the constraints are now grayed out in the toolbar. This lets you know which types of constraints you can use based on your selection. I'll click the equal constraint icon. Notice how it applies the icon to both circles, letting us know that they are tied together. Hit the escape key again to clear all commands. Then we can edit the dimension of the circle on the left. To do this, I'll double click on the dimension value. Now pay close attention to what happens to the circle on the right as I change this value to 13 millimeters, followed by hitting the Enter key. You'll see that both circles remain equal in size because of that equal constraint. This simplifies our sketch as we now only need to update one dimension should we decide we need to change it. In their current state, you'll see that I can click and drag around the outer circles. This is something that you always want to avoid. We'll want to dimension and constrain our sketches so that everything is locked into place and can't be moved by accident. I'll select the Sketch Dimension feature in the toolbar. I'm going to select the center point of the circle on the left and the center point of the large circle in the middle. As I drag my mouse cursor towards the top, you'll see that a dimension value appears. After clicking to place the dimension, we're able to define the value. I'll type out 39 millimeters before hitting the Enter key. One key takeaway that I want you to get out of this absolute beginner lesson is the idea that you want to use a combination of constraints and dimensions to fully constrain your sketches. When a sketch is fully constrained, all of the sketch geometry lines will be black. Now, the black lines signify that they can only be altered by updating our dimension values. We'll still need to constrain the outer circles, including making the distance the same. To do this, we can use the symmetry constraint. However, we'll first need to create a line to reference. I'm going to select the line feature in the toolbar. I'll then click on the center origin point and I'll drag my mouse cursor down while entering a value of 22 millimeters. Click with your mouse and then hit the escape key to clear all commands. We can now select the symmetry constraint option in the toolbar. We'll then need to select the two objects that we want to be symmetrical. In our case, we'll want to select the two outer circles. Finally, we'll need to select our symmetry line or the line that we just created. Notice how the symmetry icon now appears in both circles. If I were to change the distance on the left, then the one on the right would update accordingly. For now, I'll leave the distance set to 39 millimeters. At this point, our outer circles are still blue. If you're trying to figure out why something is not fully constrained, then you can simply click and drag on the object. You'll see that the circles can be moved up and down while retaining that 39 millimeter distance. To fix this, we can add a horizontal constraint to the main circle and the circle on the left. I'll hold down the Shift key and I'll select the center origin of both circles, and then I'll select the horizontal constraint in the toolbar. Because we already had our equal constraint on the outer circles, we didn't have to apply the horizontal constraint directly to the one on the right. Notice how the lines of our sketch geometry are now completely black, signifying that it is constrained and can't simply be selected and moved around. Now, if you toggle open the Sketches folder in the browser, you'll also see that the sketch has a lock icon overlaid on the regular sketch icon. The lock icon appears only when your sketch is fully constrained. This is a way to double check, as sometimes you won't be able to tell when all the geometry is black. We now have the basic sketch geometry of the one-hand book holder. Before we finish off the 2D sketch, let me know what you're learning Fusion 360 for. Comment below and tell me if you're learning it for 3D printing, woodworking, or other types of projects. We're almost done with our two-dimensional sketch. We have the basic shapes outlined. Now we simply need to connect them using the Arc command. While in the Sketch tab, we can select the Create drop-down list. This list includes all of the available sketch tools, as the toolbar only features ones that are frequently used. I'll find the arc flyout folder, which gives us 3 different arc options. From here, I'll select the 3-point arc. To define the arc, we'll need to select 3 points. I'll first select the end of our straight line. Then for the second point, we'll want to select the circle on the left. We want this to snap into place on the outer circle where it aligns with the center point. I'll hover my mouse over the center point first, which will give us this dashed reference line. We can then click on the outer circle where it will snap into place. For the third and final point, I'm going to click and select where the tangent icon appears on the larger circle. With the 3-point arc still active, I'm going to repeat these steps on the right-hand side. To finish off the top of this shape, we'll follow similar steps. I'll click on the top of the large circle, and then I'll select anywhere on the top of the small circle on the left. For the third and final point, I'm just going to click anywhere, as we're going to add tangent constraints in just a bit. But first, I'll repeat these steps on the right-hand side. Now that all 4 arcs are created, we'll want to add some constraints to make sure that our sketch is once again fully constrained. I'll first hit the Escape key on my keyboard to clear all commands. Let's start by adding some tangency constraints, which will ensure that our geometry has smooth transitions from one circle to the other. I'm going to select the tangent constraint icon in the toolbar, and to apply the tangent constraints, you'll simply need to select the 2 objects that you want to be tangent. I'll select the largest circle and the right side of the first arc. I'll then select the small circle on the left and the left side of the arc. I'll now do the same on the other side. I'll add the constraint to both sides of the arc, making the arc tangent with both circles. However, you may get an error message. If this does happen, you'll need to hit the Escape key and adjust the endpoint of the arc. Then, simply reapply the tangent constraint. Lastly, I'll add constraints to the bottom arcs following the same procedure. However, we won't need to add them to the middle since we want a pointy edge at the bottom where this 3D print rests in the seam of a book. Now to fully constrain the top, we can add a vertical constraint. I'll select the vertical/horizontal constraint in the toolbar. I'll then select the center point of the large circle, and then the point where the 2 tangent arcs meet. Notice how this forces them to stay at that point, which then makes the entire sketch fully constrained. We now once again have our lock icon in the browser, ensuring that our sketch does not accidentally get moved or altered in any way. This means that we can alter dimensions without our sketch geometry losing the overall shape. Now this sketch is fairly simple, but I can't stress this enough. This concept is very important as you start to create more complex objects in Fusion 360. Looking at this sketch, the dimensions clutter the appearance. Sometimes you'll find it helpful to hide the dimensions. To do this, we can simply uncheck the Show Dimensions option in the Sketch palette. Now you can also hide the constraint icons by unchecking that option. To turn this 2D sketch into a 3-dimensional object, we'll want to use the Extrude command. The Extrude command lets us add depth or thickness to a closed profile shape. The key point here is that the profile shape must be completely closed. Notice how the background color of the sketch is light blue. The light blue color signifies that we have a closed profile, meaning there are no holes or openings in the geometry. To activate the Extrude command, we'll need to select the Solid tab in the toolbar, where all of these solid modeling tools are located. You'll then find the Extrude feature in the toolbar or under the Create drop-down list with the additional solid modeling tools. After activating the extrude command, we'll be prompted to select the closed profile shapes that we want to extrude. In this scenario, we'll need to select all of the shapes except the center circle where the user's thumb would go. Once they're selected, we can type out the distance or thickness. First, however, I'm going to select the home icon next to the view cube so you can see the object turn from 2 dimensions into 3 dimensions. Watch what happens as I type out 10 millimeters. We now have a 3-dimensional part that could be 3D printed. I'll click OK to confirm the extrude thickness. Now before we export this for 3D printing, we'll want to add some fillets to the edges, which creates a nice rounded edge. The fillet command is located under the Modify dropdown list within the Solid tab. With the fillet command active, we can select faces or edges. I'll select the top face of the part, and then I'll use the view cube to look at the bottom, where I'll select the bottom face. Once both faces are selected, I'll type out the fillet radius of 1.5 millimeters, which adds a nice soft round over to the edge of the model. Lastly, we want the bottom of our model to be somewhat pointy so it sticks into the seam of the book. However, we can add a small round over to the edge to make sure that it's not sharp when the user touches the final 3D print. To apply a second fillet radius, I'll select the plus symbol or the Add New Selection button. I'll select the sharp edge, and then I'll type out a fillet radius of 0.5 millimeters. After clicking the OK button, you'll see that our model is now complete and we're ready to 3D print the model. I'm going to show you how to quickly export your model for 3D printing. Because there are so many different choices for 3D printing slicing software, I'll be showing you how to export the file as an STL file, which is the most accepted file type for 3D printers. To export the file, we'll want to select the Tools tab. From here, you'll notice the 3D print icon. After selecting the 3D print icon, we're prompted to select the object. I'll select the object or the file name in the browser. If the preview mesh option is checked, then you'll also be given a preview of how the mesh will look upon exporting. Now you can also change the refinement quality and some advanced refinement options that I won't be covering in this tutorial. Finally, you have the choice to save the file directly to your computer's local hard drive. If that's the route you want, make sure Send to 3D Print Utility is unchecked and simply click the OK button and select the appropriate folder. Now, if you would prefer to send the object directly to your 3D printer's slicing software, then you'll want to check the option Send to 3D Print Utility. Select your desired print utility from the list and then click OK. Now it's important to note that your print utility must be open before you click the OK button. Fusion 360 will not automatically open the other software for you. You can find the settings that I used to print this out along with more resources for this course at productdesignonline.com/30. That's productdesignonline.com/30. To summarize, in this lesson, we discussed creating simple two-dimensional geometry, some sketch constraints, turning the sketch into a three-dimensional object with the extrude command, and adding fillets or rounded edges. Last but not least, I want to give a shout out to all the new patrons and the supporters who have bought me a coffee over the last week. Special thanks to the new patrons Bill Butterfield and John. And also thanks to Rich Johnson, who supported the channel via my Buy Me a Coffee page. If you have found my tutorials to be helpful in any way, then consider supporting my content by becoming a patron or by making a one-time donation on my Buy Me a Coffee page. All of the contributions help me keep the website up and running and will help me continue to create high-quality tutorials. As always, I truly appreciate you taking the time to watch this tutorial. Click that thumbs up icon if you learned something in this video. and be sure to click that playlist in the lower right hand corner to learn more about Fusion 360.